Hi everyone, my name is Pavel. I want to say hello to everyone on the opposite side of the monitor and watching us. Hi, our community, our audience. GDG Minsk continues their tradition with online meetups. And before we move forward, I want to get an acquaintance with you all and introduce a bit what GDG Minsk is. Would be great if you wrote in chat where you're from and say hello to virtual neighbors. While you're replying, let me introduce what GGG Minsk is and who we are and where we're from. We are a Google Developers Group, a community located in Belarus, Minsk. The main goal of the community is networking, sharing knowledge and experience, talking about different technologies, not even necessary talking about different technologies and meeting new people and other. We do meetups and conference and focus on three main streams. It's mobile, front-end, and cloud. So if you're interested in those subjects, you'll find something interesting at our meetups, of course. How you can find GGG Minsk and join our community? It's easy. You can find us on online popular social networks like Telegram, Facebook, Twitter, and of course YouTube. I highly advise you to check our YouTube channel for previous meetups. We are online, so that is not a problem anyway. And if do not worry about it, and please contact us if in case something weird you will notice during the meetup. Last but not least, we need your, of course, feedback. Every feedback helps us to move forward. So we kindly ask you to leave feedback because everything we do is for our community. And so it's a small introduction about GDG Minsk. And today we have two presentations. Both speakers will present in English, of course, and both speakers will talk about Google Cloud technologies. I'm very excited to their speech, and now we are ready to welcome our first speaker on the page. Let me join and stream. Hi, Leah. How are
Hi,
you?
I'm fine. Thank you. It's pleasure to be here today at GDG Minsk, and I hope that what I brought you today will be really interesting.
Great, great. Anyway, I don't want our audience to wait any longer, so let's start. I wish you good luck, and I start sharing with you insight from your topic. Let's add your stream, and anyway, good luck. You can start.
Okay, thank you. So, hello everyone. Thank you for joining us today, and I'll be start talking on the patterns of cloud scaling, and today you will learn how to decide what kind of cloud scaling option would be better for your applications, would be better for your system, depending on what kind of loads do you have, depending on what kind of application and the abstraction layers do you have. My name is Ilya Kaznachev. I'm a technical leader at MTS Cloud, where we are building the Kubernetes as a service product. And also I'm a consulting cloud architect. I'm helping companies to run in the cloud, to live there and build robust and secure distributed systems. I'm a Google developer expert on cloud and also a certified cloud architect and a PhD. And let me start with basics and talk a little bit what is the scaling in general. Let us start from the classical monolithic system, like when you have a virtual machine or a physical machine with some kind of application, like it may be executable file, or it may be some kind of script like PHP script, which is running by the server or something like that. It's probably some kind of database there, like Postgres or MySQL or something like that. And probably there will be some kind of gateway, like Nginx or something else, hub proxy, etc., which will route the requests, do some kind of logging, authentication, maybe something more. And when your application is running, it's okay, everything on the same machine, there is no kind of problems. But at some point, as your audience grow, as your request rate grows, you may face some kind of issues, like it's not enough CPU, or it's not enough RAM, or it's not enough disk, etc. And uh, the general solution to such kind of problem were to buy a bigger machine and run everything there. Previously, it was very easy because machines were cheap, machines upgraded really fast. So in a half of a year, you can buy twice powerful machine on the same price. So it was not the big issue. And when the time come and the resources are exhausted, you can just buy another machine. But the problem is now it will be more and more expensive. And if we are talking about load and resources diagram, it's kind of linear relationship. But when we will talking about the money, it's non-linear. And if we will combine both together, we can see that we can upgrade the same physical or virtual machine until some point where it will not be efficient enough. It will be too expensive to do that. And that's why distributed systems emerged, like microservices, etc. And we live in a world with distributed systems. So let's talk a little bit about that. And when we're talking about distributed system scaling, first of all, I'm talking about microservice scaling. The topic probably all of us love in one or another way, but still, it is what it is, and everyone faces microservice development and microservice support and infrastructure for microservices. So let's dive a little bit deeper and take a look on microservice scaling. Uh, Normally, there are kind of three different ways to scale a distributed application. One scale is horizontal duplication from one instance to many instances. Another is data partitioning from one partition to many partitions. And the third one is functional decomposition from monoliths to microservices, for example. Functional decomposition is when we take a monolithic application with different domains and split this domain, split these parts into different deployment units, different applications. It may be functional decomposition, it may be kind of a domain driven decomposition, but the main idea is we no longer have a single deployment unit, we have different deployment units with their own life cycle and their own deployment pipeline. Horizontal duplication is when we just take one application and run a multiple replicas of this. There are the same replicas, so there is no difference between them. The only difference is probably where they are running and how to access them via network. And the third one is data partitioning. It is a bit tricky, but the idea is that when we have some kind of data storage, for example, SQL database. At some point, the single database can no longer store all of the data. It's just too much. You cannot fit into the database, you cannot fit into the disk, or maybe some kind of network bandwidth issue emerges. So we split the data into several partitions by some kind of partition key or maybe some other algorithm. But the idea is that we no longer have data stored in the single place. The data is also distributed from this point. And let's move to the cloud. We've talked about the basics. It's the same for on-premise systems, for cloud systems, for your home computers. So you can do all the same things at home on your laptop, or maybe you have some kind of server at home, or maybe a couple of computers. But when we're talking about clouds, the main reason why we use clouds is the how simple we can create and manage the infrastructure and the automation behind it, and the automation we can build on top. So let me talk a little bit about what kind of automation cloud providers give to you to make scaling a little bit easier. Let's start again with cloud basics, and cloud basics is virtual machines. So if we will look on the cloud infrastructure of any provider, let it be Google Cloud, AWS, Azure, Yandex Cloud, etc., even MTS Cloud, we will see services by layers. Layers like infrastructure as a service, as a basic layer. There are virtual machines, virtual disks, and virtual networks. Then we have platform as a service, where we may have such kind of things like Kubernetes, uh, containers, managed databases, which are running on top of the own infrastructure as a service layer. And then we will have some kind of functions as a service, etc. So the virtual machines are the ultimate basics of any cloud provider, and not only cloud provider. You may go to the hoster or something else and buy virtual machines there. And normally we have a couple of virtual machines and a load balancer on top of them, which distributes the load, the requests, network requests between these machines. And there are different types of scaling available in the majority of cloud providers. Of course, manual scaling, so you can just go there and create uh, a number of machines, and then just say, like, I want more machines. I want to have like 4 instead of 3, and a new machine will be created. Next one is scheduled. So you may create a schedule how you want your virtual machines to be scaled. Like, for example, if you are running some kind of sports related news website, you may assume that during the top games, there will be much more visitors. So you may want to scale up your service a little bit, and you may schedule these events. The next one is dynamic. So when you say can set up, like, at the same you want to scale up your virtual machine group. Let's say when the CPU is above 80% or RAM is above 70%. So if this criteria will match, the cloud provider will create more virtual machines. And otherwise, when the criteria will be matched any longer, it will shut down some virtual machines. So it will save you money and it will let you uh, handle extra load. And the next one is predictive. Not any cloud provider has this kind of virtual machine scaling, but it's that the infrastructure of the cloud provider can learn what kind of load, what kind of changes and spikes in load do you have, and try to predict when to upscale or downscale your virtual machine group. Next, uh, let's talk about the virtual machine group itself. So it's kind of a set of virtual machines with the same template, which is used to create or delete virtual machines for the same application. It normally has a minimum number of machines and the maximum number. So you will be always between these numbers. When there is more load, new virtual machines will be created until the number of machines will reach maximum. But when you have just less requests, extra virtual machines will be shut down and you will be left with minimum number of virtual machines. And even if there is no load at all, you'll still be paying for this minimum number of virtual machines. Next, let's talk about the load balancer. Load balancer is a part of virtual network which distributes the load between any hosts. That may be virtual machines or containers or some kind of functions or something else. And it normally either level 7 of OCI model, HTTP plus maybe some kind of network routing, or L4 with protocols like TCP, UDP, etc. And there are also regional and global load balancers available. So global load balancers may work that way that if you have your applications running in different regions, like in Moscow and Frankfurt and New York and Mumbai, the request will be routed to the nearest server. And also there are a lot of nice features available like TLS termination, health monitoring, different balancing algorithms, some kind of anti-DDoS, and also private and internal networking features. So we've talked about the basics, and let's move to more cloud native stuff like containers. And the idea is basically the same. We have some amount of containers with network applications on them and a load balancer which redistributes the load among these number of containers. Normally it works the following way. There is some kind of orchestrator. We don't know which one and we don't want to know, but we know that this orchestrator manages containers, run a new container, deletes an old container, some kind of memory management, disk management, etc. And when we want to deploy a container, we create a Docker file, build an image, and then push the image to some kind of container registry. It may be a Docker Hub or cloud container registry of this cloud provider or of something else. And when the orchestrator sees the need to create a new replica, it just pulls the container image and runs it, and new container joins the load balancer group. So now the load from the load balancer, from the client, mobile client or web client or something else, will be redistributed between these 4 containers instead of 3. And when talking about containers, we cannot talk about Kubernetes. So let me dive a little bit deeper into the Kubernetes world. In Kubernetes, we have three types of autoscaling. So let me just start with the Kubernetes basics and then talk a little bit more about the scaling options. Kubernetes is just a set of virtual machines with some number of master nodes, also known as control plane, and worker nodes where your containers are running. So master nodes normally uh, have a fixed amount of nodes, like 3 or 5, and the worker nodes have amount which you choose when you create a cluster, or it may be a dynamic amount of nodes, but I will cover this a little bit later. So let's start with vertical pod autoscaling. Let's say we have 3 worker nodes and some containers running on these nodes. Nodes are actually virtual machines. And here we can see that we have pin containers, blue, green, and yellow containers distributed among these 3 virtual machines somehow. And Kubernetes handles this scheduling, this container distribution among the machines. So the utilizations of resources is pretty good. And when we want to do vertical pod autoscaling, that means that some container will gain more resources, more CPU and more RAM. So it will just get more resources. And yeah, it's often used for databases, for example. The second one is horizontal pod autoscaling. Uh, the same, we have some number of virtual machines, but when the load increases, we just create more replicas. So again, we take more resources, but instead of create bigger containers, we create more containers. And that's actually more flexible than the previous one. And the next one, which is not available in vanilla Kubernetes, but available on cloud providers, is cluster autoscaling. That means when we reach some point when our existing virtual machines, our existing worker nodes can no longer fit all the load of these virtual machines, we will create another virtual machines. Actually, cloud infrastructure, cloud provider will create a new virtual machine for you automatically. So it will work like magic for you. And then the load, the containers will be distributed to this new Kubernetes worker node. And again, if we want to do task scaling, but we normally don't want to, it goes automatically depending on the CPU, RAM, or any other variable. And when that happens, the cloud provider marks one of the nodes as node for deletion and then starts to move this node to different nodes and eventually shuts down this node. And that's how it works. So we covered 2 main layers of cloud infrastructure: infrastructure as a service and platform as a service. So let us move to the next layer called function as a service. They may have different names like Lambdas on AWS, Cloud Functions on Google Cloud, or just functions on Azure. But the idea is that you simply upload your code into the cloud, you set up triggers and actions, etc., and it just works. You don't have to think about virtual machines, nodes, administration, etc., it just works. And when event happens, it triggers the function. The event can be either HTTP request or database trigger or queue message or something else, and it will trigger the function. And the nice idea behind the cloud functions is that it auto scales magically and very, very fast. So depending how many events happening during the time frame, uh, it will span more and more functions. So if you have more events, more functions will be started. More and more events and more functions. So it's basically most flexible auto-scaling mechanism available on the cloud. And another nice feature is when there is no events, it will be no functions. So cloud functions easily scale down to zero, and you will pay nothing when you don't have any incoming requests, any events in your system. So we basically covered the stateless options for the cloud, and it's pretty simple to auto scale stateless services. You just create more services, or you create bigger services instead, bigger applications, bigger containers, etc., etc. But it's still not the real case, because in the majority of infrastructures, the real deal is stateful. For example, databases or something else. So let's say a couple of words about this. It's a bit tricky, and I will start with service, aka data storage, like S3, for example. When we have S3 bucket, we just put binaries there. It may be images, video, any media files, texts, etc., etc. It doesn't matter. We just put binaries there. And in the majority of cloud providers, the buckets just auto scale automatically. You don't have to do anything. You can just put more and more and more data into the same bucket, and it will uh, upscale for you without any extra work required. There is actually a trick when the bandwidth of the bucket may be limited, so you will have to create new buckets. But probably if you don't have the system under the heavy data load, you will not face this issue. Let's move on and talk about relational databases. For relational databases, things are a little bit more difficult, and you cannot just easily make it bigger, but some clouds like AWS allow you to upscale the disk for the database. Of course, it will not always help you to fix all of the issues. For example, if you have limitations on CPU and RAM, it will be also difficult to just upscale it. You have to recreate it, and you just can't have an unlimited disk for your database. But still, it's a nice option when you're using database, and yeah, you just need to upscale the storage a little bit. But as we talk about NoSQL databases, they are normally run in a cluster. So there are amount of nodes, amount of virtual machines when the different partitions of the database running. And when we want to fit more storage into the database cluster, we just create more brokers. Or it would be better saying that cloud provider will create them for you. So you just don't uh, have to do anything. The cloud provider will create more and more brokers and will redistribute the amount of data between them. And it's very nice because you don't have to like try to create the whole infrastructure beforehand when you don't know the load patterns, when you don't know how many data will you store. And cloud provider will help you to achieve this by magic under the hood, magic of horizontal database scaling. We've covered databases, and let me say a couple of words about MapReduce, like Hadoop or Spark or something. So the infrastructure is pretty similar to Kubernetes cluster or any other cluster. There are some kind of management nodes or controller plane or something like that. So there will be one or more virtual machines which managing the cluster itself, and the amount of worker nodes where your calculations will take place. And the scaling is similar when you don't have enough virtual machines to do all of the calculations. Cloud provider will simply run another virtual machine in the same cluster, and you will get more calculation resources without doing any kind of dirty work. You just can either do a couple of clicks and upscale your cluster, or the cluster will even do everything for you automatically. And as for queues like SQS, Kafka, etc., pops up, uh, the same works for message brokers. You normally have some kind of cluster of several brokers, and when you have to upscale the cluster, cloud provider will simply install it, set up it to work together with other nodes in a cluster, and it will magically give you more resources to land the data, to land the messages into the cluster. And at the ending, I would like to say a couple of words about, let's say, super services. So each cloud provider uh, has a number of its own, like, rockstar services, like in Azure, in AWS, in Google Cloud, like Cloud Spanner, Bigtable, Firebase, DynamoDB, Cosmos DB, etc. And what's important is that these services already have some kind of auto scaling inside them, but you will not see this kind of auto scaling. So you will not see the number of nodes in the database. You will not see scaling options. It will just work automatically for you. So you can just put your data there, and the cloud provider will do the magic for you. And you will just pay for the amount of resources or the amount of requests, and everything else will just magically happen inside of the cloud provider. And that's actually why I like cloud providers, because they try to free you from the administration work, for database administration, for infrastructure administration, and give you just an API to use your cloud infrastructure, to use your databases, to use your uh, container orchestrator, to use your, I don't know, something else, and you can simply don't think about all of these topics. It will magically happen for you. And yeah, that's all for today. Thank you for your listening, and I would like to answer your questions.
Yeah, thank you very much for your speech. So it's really interesting for me, and I noticed some important, so new interested information for me, of course. Well, we have not so more questions, but we have one more. The question is, what do you think? Do the team should have a separate DevOps engineer, or team should be able to distribute it on servers? I can repeat. Ilya, are you with us?
Can you repeat the last part of the
Looks,
question, please?
yeah, sure. Looks like you have
Because
a
the connection is not
internet
very good.
issue. Can you hear us?
Yeah, I can hear you, but I missed the last part of the question.
Right. Sure. What do you think? Do the team should have a separate DevOps engineer, or team should be able to distribute its own servers?
So it depends. Thank you for the question. First of all, it depends on the requirements and on the needs. So if you want to have more control on your infrastructure, like when you want to use specific operation systems or a kind of drivers on top of the operating systems, like for 3D modeling or something like that, you probably would like to choose more low-level options like infrastructure as a service and manage everything by yourself. So the cloud provider will give you the basic infrastructure, and then it's your turn. You will set up the operation system, you will patch it, you will upgrade it, you will uh, install all of the system libraries and requirements and your applications, and you will manage them with a DevOps engineer or probably a DevOps team. But on the other hand, if you don't have to do this, if you just want to run your application in the cloud, if your application is kind of cloud native, like it's stateless, it containerized, you can just put it into container and set up something like Google Cloud Run or Heroku when you just run container in the cloud infrastructure, and thus have you don't need a lot of DevOps work to do. You have to set up CI/CD pipelines. You have to set up some kind of um, repository, and that's basically it. And if you just want to run your code in the cloud, you can use any kind of cloud functions and just don't have DevOps at all. But normally, you will not have so much control on your cloud infrastructure. So it depends on the needs of the product and of the company itself. So some companies are forced by laws, but by government regulations, for example, to like run some kind of audit logging on the virtual machine. So then the cloud function is not the option for them. But I would say that if you're a startup, if you're a young company and you don't know how many users you will have, how big will be the load and the amount of storage, try to start with options with less administration, like Kubernetes or even containers or even cloud functions. And then when you will feel your limits, when you will understand the scenarios of data flow through the system, you can play a little bit with that and finish with infrastructure as you want it to be, like Kubernetes based infrastructure, which is best option for today, I think, or even a virtual machine based infrastructure when you will have more control, but you will be 100% sure why you want to have such kind of control. Yeah, that's it.
Great. So your your answers look like a small speech anyway. uh, Next question is: do you have a site reliability engineer in your team?
We don't, but as we work with a kind of DevOps domain, so inside of the cloud provider, our clients are mostly DevOps engineers. We first know a lot on this topic, and we implement SRE practices in our daily work. So we don't have such kind of team of SRE engineers. We don't have such kind of team of, I don't know, something else. We just all work on this topic. We try to implement different practices like disaster recovery plans, like something else, like like SLAs and all of this SLA, SLO, and SLI related stuff to make our more and more pleasant for customers. And that's not only just a thing that we wanted to do this because it's a fancy thing. It's, Google does that, and that means we also want to do that. No, it's just necessary, because if we will not do that, we just will be unable to build reliable enough infrastructure to meet our requirements. And our requirements is our main requirement is for nines of infrastructure and service availability and the process success. So yeah, we do a lot of work on this topic to make the whole infrastructure reliable and disaster tolerant. Yeah, that's it. So if you have really big, really strong requirements on resiliency, on fault tolerance, or on disaster tolerance, you will be forced one way or another to implement SRE practices, and not only on the infrastructure layer, but also on application layer. So these two parts always work together.
Right, great. Next questions
Hope I
from
answered your question.
looks like yes. Is how do you monitor your service in the cloud?
Okay, so again, there are several options. First option is to use what cloud provider gives you, and the majority of providers have some kind of monitoring uh, monitoring solution, monitoring product for you. For example, in Google, there is a set of observability tools for logging, for monitoring, for tracing, etc., etc., and you can just use them either by native API or by means of some kind of standard like OpenTelemetry. The same goes for AWS, the same goes for Azure, etc. Another option is to use SaaS product like Datadog, like there are a lot of them, and they're pretty good actually. So uh, there are many players on this market currently, and some of them gives you really nice opportunities like machine learning to predict some kind of failures, will help you to analyze the all of these metrics, all of these traces and logs will be transmitted via costs a little bit more. And the third option is to run your own observability infrastructure like ELK, like Jaeger, like something else, Victoria Metrics, and set up your own serves like Grafana, etc. This works better for bigger infrastructures because it costs you more. Again, it gives you more control, but costs you more labor. But you can be more flexible in exchange of more work and more possibility to do something wrong. So it's up to you to choose. Again, when you start in your company, when you start in your product, I would advise to use existing cloud options and then move to something else.
Right. Thank you very much. I have a one. So we don't have any questions from our audience, and I would like to ask you my own question. And the question is, how to handle errors and do not go crazy of it. I mean, we have a lots of service in the cloud, and as well they provide for us lots of errors and how to handle all of them.
That's a great question. Thank you for that. And I would say that errors is something related to your code, your tech stack, let's say, but how we handle them is related to organization and the organizational culture itself. So since we run our applications in some unknown environment, like somewhere on the remote server, on the remote rack, in the remote data center, we don't have direct access there. So even if we run on virtual machine, we can log in via SSH and see logs. But when we run in Kubernetes, we may be limited in options. And when we run just containers, the options will be even less, even more limited. So in this case, you will still have logs, you will still have tracing if you will implement it, and monitoring. But to be able to handle the errors, you have to build right processes. Like when something break, you just don't have to go crazy, run around and try to fix something fast. You have to understand what to do in each case. You some things like alerts, like monitoring and distributed tracing will help you. First one will notify you probably before the bad things happened. And the second thing, the distributed tracing will help you to localize the error faster. Like you can just open the trace and find in which service the error is. But to be able to fix them like a pro, you have to again implement SRE practices inside of your company. Some practices are harder to implement, but some of them are much simpler, like post-mortem. It's the practice when when something breaks and you sit together with your colleagues and try to understand what happens, why, and how to fix that. But what is most important, you don't want to find who is responsible for this because you are the team. You are everyone in the same boat. So it's not important who broke that. It's important how to fix that and set up a bunch of tasks to fix each part of this big failure. So that's where you can start. Try to learn about these SRE practices. Try to implement as much practices as you can. And during this process, a lot of errors will just gone because you will have right processes, which will help you to eliminate the majority of problems.
Great. So it's wonderful answer. I'm really grateful to you. Anyway, thank you very much for your speech, interesting knowledge you share to our audience. And I want to say, try to create a new, interesting speech for our further meetups. And good luck in your next investigation in from how to say in a cloud world.
Yeah, thank you. It was a pleasure for
So
me to participate.
yeah. Anyway, thank you very much. So we go further for another for the next speaker. By Liam.
Hi.
We have a second speaker, so it's Rob. But as you understood, we have technical problems right now. Rob on a second meetup, so he busy on other side of meetup, and now we are watching a pre-recorded video. So try to relax and watch the video.
Hi, welcome to GDG Minsk. I'm Rob Richardson. I'm excited to share with you Level Up DevOps with GitHub Actions and Kubernetes. This is a fun talk where we will build a DevOps pipeline live and deploy a container into Kubernetes. Here's the part where I tell you I am definitely going to post the slides on my site tonight. But in this talk, there are no slides. But I'm definitely going to post the code on my site tonight. It's up right now. Let's head up to GitHub and we'll go to Level Up DevOps with GitHub Actions and Kubernetes, and it is online right now. Well, kind of. The repository is empty. We're going to fill that. So if this is a little bit difficult to get to, you can head to robrich.org, click on Presentations at the top, and here's Level Up Your DevOps with GitHub Actions and Kubernetes. And so robrich.org, click on Presentations, and you can get straight to the GitHub repository. So while we're here on robrich.org, let's look at some of the things that I've done recently. We'll click on About Me and see this page. I'm a friend of Redgate, a Docker captain, and a Microsoft MVP and MCT. I'm also a Jetpack developer advocate, where we work on deploying to Kubernetes really easily. AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities to build free software. We start Friday after work. Sunday afternoon, we deliver the completed software to charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp here in Minsk or wherever you're watching from, hit me up on email or Twitter, and let's get a GiveCamp in your neighborhood too. Some of the other things that I worked on: Pro microservices with .NET 6. That was a lot of fun. I got to work with Sean and Matt on that book, and you can grab that right now. And I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woo! So there's my claim to fame, my coveted .NET Rocks mug. So let's dig in. We need to build a website so that we can push that into a container. I've got an empty folder here. I'll pull that up in VS Code. And let's start off by creating some content here. There's nothing in Kubernetes, nothing in this directory. Let's say .NET new, and if we do .NET new, it will give us some options of the type of projects we can create. Now, ultimately, we could create a Python app or a Node app or a Go app, but in this case, I'll just say .NET new, MVC. I'll give it a name of Level Up DevOps and an output folder of the current folder. Now, if I didn't pass in a name, it would use the folder's name, so in this case, demo. And if I didn't pass in an output folder, it would put it in a new child folder. So now we've got that content and we've got a website ready to go. Now this is a regular website, so we have controllers. Here's our home controller, and it renders our index view. So if we go into views, we can see that index view. And rather than just welcome, let's say welcome to GDG Minsk. Now that we've got that website in place, let's start to containerize it. Now the first thing we need to do to get ready to push this up to GitHub is to create a .gitignore file. Now here in the .gitignore file is everything that we don't want to push up to our GitHub repository. So we want to ignore built files. We want to ignore user-specific files. We want to ignore downloaded libraries. Downloaded libraries. Ooh, we'd like to add VS Code things. Yep, let's put the .vs Code folder in here. So built files, user-specific files, downloaded libraries, temp files, and secrets. Those are the 5 things that we don't want to end up in our GitHub repository. So built files. In this case, the built files for a .NET project are bin and obj. User-specific files. We don't want star.user, the .vs folder, maybe this .vs code folder. Downloaded libraries. Now we might have a node modules folder if we include JavaScript content for our client-side app. In this case, we don't have a packages folder because we're in .NET Core. Temp files, star.tmp, star.log. We might say star.orig, a file that we get when we're merging content inside of Git. And then secrets. Now we don't have any secrets in this project per se, but it would be really easy for us to accidentally put secrets here in our app settings. So we really want to use user secrets instead. Okay, so we have our gitignore file. That's perfect. Now with our gitignore file, we want to specify all the things that won't get committed to our repository. Next, let's take a look at how we can move this to a container. Our first stop is to create a .dockerignore. Now it's a .docker, so if you're in Windows, you can make a .dockerignore file and that will create it, or you can come into your editor of choice and make a file that says just .dockerignore. But sometimes Windows gets a little mad at those things that only have an extension. Now, in our dockerignore file, we want all of the things that we ignored in our gitignore file, but we also have one more category, which is development content. Oh, I guess in secrets, we might have a .env file. Let's put that here in place. Okay, so we don't want to commit production content. Now, development content rather. So we have an app settings development JSON, so let's ignore that. We don't want that in our production container. We also have here this launch settings.json. And that specifies all of the details that we would need to be able to debug our application, a development environment, the various ports, and we definitely don't want that in our production Docker container. Okay, now the cool part is this has the exact same format as our .gitignore file. If we don't have a .dockerignore file, but we do have a .gitignore file, then Docker will use that as well. Now this specifies everything that will never end up in our container. So even if we specifically copy a thing from our host machine into a container with one of these names, it won't end up in our container. So now that we've got our dockerignore file, let's create a Docker file. New file, Docker file. Now it's important that it's Docker file and not dockerfile.txt. So if we accidentally made it a dockerfile.txt, we can pull that extension off and it is just Docker file. Now I have the VS Code Docker extension installed, so I get the pretty icons. Here in our Docker file, we want to focus in on the 4 verbs that help us understand Docker. From, copy, run, and cmd. Now there are other Docker commands, and we'll see some of them today, but these are the 4 main Docker file verbs that we'll use. Now each of them allows us to be able to do various things with our image, and ultimately these 3 get run at build time, and this last one is the command that we launch our container with. So if you know these 4 commands, you can probably read and write most Docker files. That's elegant. So we want to what is our base image? Let's head off to Docker Hub and we'll search for .NET And we'll end up on this repository here that specifies the various .NET repos that we can use. Samples is great, showed lots of different Docker files and interesting scenarios. Monitor is fun to be able to take a look at various pieces inside of .NET. Runtime deps is everything we would need to install Docker, .NET rather, but without .NET installed. On top of that is the runtime that allows us to run console apps. Built on top of that is ASP.NET that allows us to run websites. And the SDK is the build tools that allows us to build .NET applications. So let's pop open this, and we'll use this as our base image. Now here we can see that that's the base image right there. And if we scroll down a bit, we can see the other flavors of this image. Now 6.0 is the one that they suggested, but there is an Alpine variant. Alpine is a much smaller Linux distribution, so let's use the 6.0-Alpine variant of this base image. So from that -Alpine, and now we've got a base image that includes not only the .NET runtime, but also the .NET build tools. Next, we're going to copy all of our content from the folder where we run the Docker build command, we'll run it in this folder, to the current folder inside the image. Now what is that folder? Let's specify a work dir of /src to be able to specify how we want to copy that content into place. Now we could definitely put it in var lib foo bar or wherever we wanted to put it, but /src is a good spot for that. Now, inside of a container, we don't have different mount points in different places, so we'll all end up with exactly one volume there inside of src. That works out great. So we just copied all of this content into place, and now we want to run some commands. Now, if we were on the CLI, we would do some various techniques to be able to get our .NET app into place. .NET restore, that would restore all of our NuGet packages, all of our dependencies. .NET build, we want to build in release mode. .NET test, we'll also do this in release mode to make sure that we don't end up with one release mode 1 and one debug mode 1. This will run all of our unit tests. Now in this case, we don't have any unit tests, so it'll just be a no-op. Next, we want to do a .NET publish, and we want to do that in release mode to the dist folder. Now this is not unlike doing a right-click publish inside of Visual Studio. It collects all the content that we need for our web server, all the built DLLs, all of the client-side files, and puts them into a folder, in this case the dist folder. So we'll flip over our work dir to the dist folder, and then the command that we want to start our app will be .NET level up devops.dll. Now we do need a few environment variables. Let's set those in place. We have an environment variable here that tells .NET to run in production mode and what port to run on, and we'll expose that port so that we can connect to that through the Docker router. Now we've got a Docker file. Oh, these are the commands that we'll run, and so we need to run them as part of our Docker file. So let's run this one, let's run this one, let's run this one, and run this one, and now they'll run and do all the things. Now the cool part is, if a build fails, it'll stop here and not go farther. If our test fails, it'll stop here and not go farther. So we won't get a full image unless our build and tests pass. Excellent. Now we could definitely use this image in production, but there are some things that we need to tune up. One of the base rules, one of the best practices inside of Docker is to avoid compile tools inside your production images. Now right now we have the compile tools, we also have our source code, even though we don't need it. So let's go back to Docker Hub and flip back over here, and we'll open the ASP.NET repository. Now here we can see that we have this image, so we'll go grab that name right there. Here's the Docker pull command that'll get us there. And we see that we also have an Alpine variant as well. So let's split this in half. I'm going to put this from there, Alpine, Alpine, and now we have two parts. This is our production runtime server image, and this is our build server image. Oops, that is this. Now, this build server image is all of the build tools and all the things that we need to do it. And then we flip over to this new stage where we just have the details that we need to be able to run our system. So we're basically building two images in this. Now, because we'll only specify the latest one, this server image will be the one that will actually tag and push, and this build image will get thrown away. Now, we do need to do a few things a little bit differently. We need to say we'll make worked app, and we need to copy from the dist folder into the current folder. But right now, if we did this, it would look for a dist folder out here. That's not what we want. Instead, let's copy from equals build, and let's call this one as build. We've just named this stage as build. We could definitely call this one as prod or as publish, but we don't need a name for this one. We're not going to use it. So now we've copied that dist folder, and only the dist folder, not the source code, into this new image, and it will run in a really, really lightweight way. So that's great. We no longer have build tools in our production runtime image. The other thing we can do is take advantage of Docker's caching. Now, each command is a separate layer in our image, and each one is cached. So right now, it copies in all of the files. If I came in here and I changed just a JavaScript file or a CSS file, it would invalidate this layer. Then it would do a .NET restore, grabbing all of my libraries and dependencies, and that download takes a little bit. So really, I want to do that first, and then copy in all my content. Now, I still do need to tell it the manifest, so let's copy in level up devops.csproj into the current folder, and now it has that manifest that it needs to be able to know what packages it restores. But now, if I'm just doing a quick adjustment in development, then I'll invalidate this layer, and I won't need to reinstall my dependencies. That'll make my builds much faster locally. On a build server, it's still going to probably restore all the things, and I want it to start over from scratch. So I think that's good. Great. Now we have a Docker file that allows us to build, test, and then flip over to a new stage to make that a whole lot lighter weight. So we've got a Docker file. Our next piece is a Kubernetes YAML file. And Kubernetes YAML files can get pretty hairy, so I'll just pull in the one that I used last time. Let's copy that into place. And here is that Kubernetes YAML file that I used last time. Now, I want to switch it over to do the things that I need for this time. So I'll hide last time with level up DevOps. And now it can work for this project instead. So we've got a deployment that specifies a container, and we have a service that will load balance across all of them. In this case, we only have one instance. And then we have ingress that will match DNS here to our particular service. Now we do have some replacement expressions that will change in our build to ensure that we don't end up with secrets inside of our source control. For example, the image label. Now this will be different on every build, so we don't want to hard code it into this Kubernetes YAML file. And our repository URL, our Docker Hub repository, or in this case, we'll use a private container registry. We also have the AKS URL, the URL of our Kubernetes cluster. And so we don't want to commit that into source control either. So we will commit this file together with the replacement expressions, and in our automated build, we'll plug in those replacement expressions. That'll be great. So let's grab one more piece. Let's create a new file, and we will call this readme.md. And here in the README file, we'll put in some content that explains our project. So that looks good. Now, we've got our website, we've got our .gitignore, we've got our Docker ignore, we've got our Docker file, and we've got our Kubernetes YAML file. We're ready to commit this up to GitHub. So here in VS Code, we can take a look at this. We'll look through and make sure that we have ignored all the files that we wanted to. We will ignore all of the built content, all of the libraries, user-specific files, and secrets, and ensure that we don't, temp files, and ensure we don't push those up into our repository. Level up your DevOps. commit that. And now that we've got it committed, git status, let's push that, git push origin main. So now if you're following along and trying to grab the source code for this, now it is up on GitHub. So when we flip back to our project, we can see that we now have content in our repository and we can start to do this automated build. Perfect. Now, this wasn't quite a completely empty repository. I did set up some secrets previously. I went here into settings, I went into secrets, I went into actions, and I defined some secrets here. A secret for logging into our container registry, a secret for our Kubernetes cluster URL, and the kube config that we need to authenticate into our cluster. So I just went in here and I said new repository secret. I gave it a name, and I could give it any name, your name here, and gave it a value, some value, and created that secret. Okay, next up, let's get into GitHub Actions. So I'll click on Actions here, and I can choose from various templates. .NET Desktop app, publish a Docker container, build and deploy to GKE. That looks really interesting. We could build various things, and there's a whole lot more categories and examples here. Now, in my case, I'm going to set up a workflow yourself. Just start with a blank one. Now, it's not quite blank, but it's pretty close. Let's say Docker build and push, Kubernetes apply. Now, when do we want it to run? We want it to, let's do it this way. There we go. We want it to run on our main branch. Now, we'll come back to pull request. That'll be fun. We'll do that later. And we want this workflow dispatch. Now, if we have this workflow dispatch, we'll get a run button here that we can push. So we don't need to commit whitespace just to kick the build over again. Next, let's build some content. Now, we have one build stage called build. It will run on Ubuntu. And here's the steps that we want to do. So our first step, it will check out our source code. That's perfect. And then we can grab various scripts that we want to run. Now, I'll delete the single line one. We only need the multi-line one. And let's say this one is Docker build and push, kubectl apply. Excellent. Pardon me. So this is what we want our build to do. So let's delete these. And we want it to say Docker build, and we'll build in the current folder. And we want to tag it. So let's tag it as level up DevOps. But we need to tag it with our registry URL. Good thing we created a secret. So how do we leverage those secrets? Yep, we went into our settings, we created our secrets. Now we can use this syntax to be able to include the secrets inside of our scripts. So we do $, secrets, and then that secret name to be able to leverage it. So let's come back in here and let's do that. $, secrets.acr URL. And now we've got our registry URL in the name of our image so that we can push that up to our private registry. And let's also give it a version. I'm going to say github.sha, and that is the git hash for this commit. Now that definitely isn't semver, but it will be a unique container per build. If I change my source code, I'll get a new GitHub SHA. And the beauty of this is that if ever I want to get back to the source code that created this image, I know exactly what the GitHub SHA is that I need to check out. So I find this to be a really good way to version my content. Next, I want to Docker push this image up to my private registry. And so there I've got the details that I need. Now the interesting thing is, in this case, it's going to fail because I haven't yet logged into my registry. Let's come here into the GitHub Marketplace and take a look at various commands. So I want to do a Docker login and, a Docker login. Let's take a look at this one. Yep, I can dig into the full Marketplace listing, and that will show me additional details about this action. What are the various configurations? How might I choose to use it? And that's really interesting. I can probably link directly to the source code here too. But in this case, I'm just going to copy the YAML that I need and I'm going to put it right there. Now I do need to indent it correctly. There we go. And so now I have the details of how to log into my registry. Now it wants a registry. Good thing I have a secret for that, secrets.acr URL. It wants a username. I've got a secret for that. So let's do the ACR username. It needs a password, so let's use our secrets ACR password. And we don't need ECR. Now, then we have a logout section. Now we want to set this to true to remove our secrets after the build finishes. Now that isn't after this step finishes, but rather after this entire build finishes. Now if we're on a shared build agent, that's good code hygiene to delete our secrets so they don't accidentally leak into the next build. In this case, up on GitHub Actions in our shared build, we're going to automatically delete all of the secrets after, automatically delete our build agent after every run. So I think we might be safe. But good code hygiene, let's definitely delete the secrets. Now that we've logged into Docker, when we do a Docker push, then away that goes, and we've got our content in place. Next, we want to do a kubectl apply-f k8s.yaml, and that will, where did we go? There we go. That will run our content inside of Kubernetes. In a similar way that we logged into Docker, we need to log into Kubernetes as well. So back in the marketplace, let's look for kubectl set, Kubernetes set context. Okay. Let's take a look at this one. And we've got some options there. We could definitely look at the full marketplace listing, but let's grab that one and set it into place. Okay, I need to indent it correctly. There we go. Now we want our cluster type. Nope, we want our method. There we go. The default is kubeconfig, and that's what we're going to use, so that's perfect. And because we're using a kubeconfig, we don't need the rest of these. Those are the different options for the other methodologies. And our kubeconfig, we have a secret for that, secrets.kubeconfig. And I got that out of the .cube folder inside my local machine. Now it definitely has secrets in it, so I'm not going to pull it up. But I grabbed the details from my cluster and I set them inside the secret so that I can log into Kubernetes. Okay, so we're logged into Kubernetes and we'll apply this. Now we did have some replacement expressions here inside our Kubernetes YAML file, image label, ACR URL, and AKS URL, so let's replace those next. Back in our GitHub Actions build, we want a new step right here that will do that replacement expression. Now I'll just copy this to avoid, to speed up the typing there, because this command is pretty intense. We want to sed the content. We want to replace content using sed, and we'll do that inside of our Kubernetes YAML file. Now we're going to do it without a backup. We're going to look for the string ACR URL and replace it with a secret. Look for AKS URL, replace that with the secret, and look for image label and replace that with GitHub SHA. So that will put all of our secrets into our Kubernetes YAML file. Now I specifically did it here after I pushed the content into Docker Hub, or in this case, a private registry. Now, why would I do that? If I did that here, then I might accidentally end up with my secrets inside of my container, especially if, for example, here in my .dockerignore file, I forgot this secrets. I forgot to put the k8s.yaml file here in my secrets because I forgot. And if I put this line ahead of my build, then that secret would end up inside of my container, and then that could possibly leak my secrets if my container got popped. So let's not do it there. Let's put it after we push to make sure that those secrets definitely can't end up in my container. Excellent. Now let's call this Docker build kubectl kube apply, or I'll just call this Docker Kubernetes. There we go. Now I'll commit it. this just becomes one of the, add GitHub actions, and I will commit this file. Now this just becomes one of the files inside my repository. So we can see inside the .github/workflows folder, we have this Docker Kubernetes YAML file. Now if I come into this file and I choose edit, I'll get back directly to that editor experience where I can go reach into the marketplace and do things. But because it's also just a file in my repository, I can come back in here and I will do a git pull, and now it's just one of the files here I have in my project. So here's the .github folder, the workflows folder, and here's the Docker Kubernetes build, and we can continue iterating on it locally. Now because there is a file inside .github/workflows, we will also kick off a build. So we can see that a build started, and we can dig into the details of that build and see what it's doing. Now this is going to do all of those steps inside of our GitHub Actions file. It's going to do a Docker build, which will then do all of the build steps inside of our Docker file. Restore our dependencies, build our content, run our tests, publish that content, flip over in a new image, and then push back outside of our Docker file inside of our build file. It will push that up to our registry and ultimately start it on Kubernetes. Now it's now running inside of Kubernetes. Let's do kubectl get all, and if I hurry, I might be able to see it starting or pulling. Nope, it's already running. Now it takes a while for DNS to propagate for the DNS entries that we added, so let's see if we can proxy our content into place. We can port forward into a specific pod, or into a deployment, or into a service. Let's do that. Let's port forward into a service. That'll skip our ingress, but it will allow us to flex everything else. So I'm going to do that here. kubectl port forward service /level up DevOps, and I'll forward port 80 from my local machine to port 80 inside the container. But maybe I'm running something on port 80 on my local machine, so I'm going to flip this over to port 8080 on my local machine. There we go. Now that we've got the port forward set up, we've got a direct link into that image. So let's come back here and we'll go to localhost 8080, and we can see our website is running. Excellent. Now that was great. We were able to create a website, build a Docker file, push that up to GitHub, create a GitHub Actions DevOps pipeline, and deploy that into Kubernetes. Now there are a few things that we skipped. Let's come back to a pull request. So I have this Docker build and push Kubernetes apply step. Let's copy that, and let's create a new file, and we'll call this Docker PR. Now, we could definitely here say, give us conditional steps like if always, or if the branch matches in a similar way. But our pull request build is going to be substantively different. So let's actually come back in here and do that. We definitely don't want to apply it to Kubernetes. Oh, did I change it? Nope, Docker build a PR. There we go. We definitely don't want to deploy to Kubernetes, so let's remove that kubectl apply line. Because we're not deploying to Kubernetes, we don't need to log into Kubernetes, so let's delete that section. We also don't need to set our secrets for Kubernetes, so let's delete that line. We don't want to push our image into Docker Hub. We don't accidentally want to deploy a version from a pull request into production, so let's delete that line. That also means that we don't need to log into our private registry, so let's delete that line. And so we're left just with the Docker build. Now, we could even go a step farther and say, I don't even want to put my registry URL there. I'm just going to say this is tagged with that label. Now, the cool part about this, Docker build a PR, is it's still going to do all of the steps inside of my Docker file. So looking back at our Docker file, we're still going to restore all of our dependencies, we'll build, run all of our tests, publish that content, flip over into the other container, and get ready to go. Now, we're not actually starting this image, but we've built it. So it will still do our full build, restore all of our dependencies, and validate our software with all of the unit tests. It just won't publish anywhere. Now we want to do this on not main, and we want to do pull request branches, all branches. Now, why do we have two parts? For collaborators in this project, they might have a different branch. Maybe they have feature / something or other. For outside contributors, we have pull requests coming in. So we want to be able to build on everyone's local branch, and we want outside contributors' branches to build too. So that's why we have those two pieces. And we have that workflow dispatch so that we get the manual build too. Now, it also could be cool for us to put a status badge here on this README file. So let's reach into our GitHub action and take a step back and dig into that build, and let's go create a status badge. I will copy the status badge markdown, set that here in my README file, and now we'll have a green or a red build associated with this, this change. So let's close all the pieces, come back in here, and we'll take a look at it. I'll stage all the changes. Let's take a look through. Ooh, I'm glad that I ignored that k8s YAML file. I don't want that to end up in my production container. That might leak secrets. We've got our README with the status badge there. We also have this new build. Nope, actually it looks like I have some white space differences. I trimmed some spaces off some things. And here's our new pull request build. That looks great. So let's say add PR build and status badge, and we will commit it. Now, last time we pushed from the command line, we can also push from here. So we will push this up to our repository in GitHub. And now if we come back to GitHub, we can see that not only do we have our content in place, but we also have that new PR build as well. So now what's interesting, because we made a change on the main branch, it did kick off our regular build. Last time we went in this way, let's go in the other way instead. We'll click on Actions, and then we can choose from our particular build, or in this case, we're in all workflows, so it'll show them all. Here's that build that we just kicked off, and we only have one stage in that build, this stage, and so it's going to do all of the steps here. Now it did a Docker login, it did a Kubernetes set context. Now it enters into our Docker file where it's going to restore our dependencies. It's going to run the build. Looks like the build succeeded. Run our unit tests. We have no tests, so they all succeeded. And then publish into the new stage. We'll take that new stage, push it up to our container registry. And then once it's in our container registry, we will start that new site up on Kubernetes. So now the version that we have running inside of Kubernetes is our new version. kubectl get all, and we can see our new content is running in our cluster. If we take a look at this pod, kubectl describe this pod, we can see exactly what git hash built it, and that is the version of our software that is present in this pod. 0e73cad. If we say git log -- one line, we see that that is the version of the software we just built. Excellent. So we were able to do a pull request build. We were able to add a GitHub status badge. And so here's that status badge. It says that the build is passing right now. Excellent. Now this has been awesome to be able to build up a DevOps pipeline and get a new website from scratch all the way into running in Kubernetes here. I would invite you to clone this build. You can go to robrich.org, click on presentations, and get straight to this GitHub repository. Or let's put this repository URL in chat, and I look forward to joining you in that spot where GDG Minsk has designated for the live Q&A. I'll see you in a minute. If you're watching this video later, hit me up on Twitter at rob_rich, and let's continue the conversation that way. Thanks for joining us today.
Hey, so time to ask Rob and introduce himself. Hey, Rob.
Hi.
How are you?
So glad to join you here.
Right. So you are switch from one meetup to another meetup. So you're
Yes,
CEO of meetups, right?
right.
Yeah. So we, let's try to figure out on our questions. So we have pretty much of them. And
Mhm.
first question is what about testing and the result after testing? It's easy to integrate it into overall pipeline. Oh,
Good question. There's a couple of approaches that we can take here. Once we get our test results, they'll probably be in an XML file or maybe another format. There's a few GitHub actions that allow us to take those test results and build results inside of our GitHub Actions build that will enumerate those test results. The one that I really like is called Test Reporter, and that allows us to build a really detailed view of all of the test results and show us which ones succeeded, which ones failed, and that's really elegant. The important part here is that that publish test results step needs to come after our build step. But because it comes after our build step, if our build failed or our tests failed, then it may not need to run. So we do need to specify inside of our GitHub Actions step for publishing test results, we do need to say if always to be able to always run it even if our tests fail. There are other test results actions that can make it part of our GitHub run results, show up in our pull request, for example, as the failure reason. Or we can take a different approach of uploading these as part of our build artifacts. Maybe we need to upload them as part of our artifacts to be able to integrate with another dashboard. Maybe we're pulling it into a dashboard associated with Octopus Deploy or with our corporate build environment. And so uploading the test results there might be a really elegant solution as well.
right. So next question is, oh, how would you this solution change if I wanted to also deploy my PWA, SPA, or and how would I also deploy my Angular or Vue or React app alongside my server API?
That's a great question. Now, if we have a mono repo that has both the Angular app and the backend app in one repository, then we'll probably build two different builds that look at different paths within our application. But if we don't have a mono repo, if we just have a repo per system, then we'll have two different GitHub actions, one in each repository. Now, the one that we built here was a backend build. So we did a build, and then we did that publish step into a new phase, a new step in our Docker file. We have a multi-stage build, so we've got a new stage there. And we'll do a similar thing with our Node or with our Angular or Vue or React app. We'll do an npm run build, and that will build all of the static resources that we want to host. Now, maybe we choose to host them inside of a container, in which case our second phase in our Docker file is hosting those static files. But the interesting piece is we might choose to not host them inside of a Node container, but rather an Nginx container. They're just static files after all. Or we might have a build that could push them up to static file hosting like Azure Blob Storage or Amazon S3 or Google's Blob Storage. And at that point, then we don't even need to run a container. They're just static files. So that might be a cheaper way to be able to host these static resources for our progressive web app or our single page application, our PWA or our SPA. So how does the build change? We're just running different commands. In the case of our backend, we ran .NET build and .NET publish. In the case of our SPA build, we would run npm install and then npm run build. That's all.
Wow, wonderful. Next question is, are there any big difference using GitHub Actions for example Jenkins? What do you suggest here if need to choose one? Or maybe something different things. Example Team City.
Good question. There's lots of different build servers. GitHub Actions is one. We could use other cloud-based systems like Travis CI or Circle CI, GitLab. There are other on-premise solutions, Jenkins, TeamCity, and there are others. And we could build our DevOps build in any of them. The magic of what we did in our build was in those 4 lines at the bottom. If that process got any more complex, we might even choose to put that inside of like a build.sh script. And then from Jenkins, we just need to do those same processes. We need to log into our Docker container registry. We need to log into our Kubernetes cluster. We might use Jenkins plugins for that. And then we run our build steps. So, run a shell script. And in this case, we could just run the Docker build, Docker push, set the secrets into place, and kubectl apply. And or we could run build.sh if the build got any bigger. Now, Jenkins and TeamCity and GitHub Actions and GitLab all store their secrets ever so slightly differently. So we will need to change the syntax to be able to run the Jenkins plugins and to pull the secrets from the Jenkins secret store. But other than that, the methodology of how to create this build is the same. So whatever build server makes you happy, definitely leverage that and take this same methodology and build up your DevOps pipeline there. If it's Jenkins, then by all means, that could be great. Now, you did ask about how would I choose a build server? My first step might be to take a look around in the organization. Have we standardized on something? If we've standardized on Jenkins, then me pushing TeamCity is probably not going to get far. But if we haven't standardized on something, then we might want to compare features or cost or capabilities. And the cool part is Jenkins is free and open source. We do need to get a server to host it on. So maybe we have difficulty getting an on-prem server, or maybe we need to spin up a compute server inside of Google Cloud to be able to run this build. And so at that point, the cool part about both Travis CI, Circle CI, and GitHub Actions is they do have a free plan that is cloud hosted, which means we don't even need a server to host it on. So if we're focusing purely on cost, GitHub Actions or GitLab or Bitbucket might be interesting things to investigate. Ultimately, at this point, a lot of the build servers are pretty competitive in both features and pricing, so I don't think you can really make a bad choice here. The worst choice would be to not create an automated build. So provided that you're eager to create a build, then ultimately I support you in the tool choices that you make. Find the one that makes you happy, really lean into it, and build some automated builds so that you get some automation, you get consistent unit test runs, and you get consistent deployments into your production environments. That's the important part here, the automation, not so much the brands that accomplish it. Great question.
Right, yeah. So your answer looks like a small introduction for a big for the next meetups, I guess.
Yeah, that sounds like fun.
Yeah. So it looks like the second next question is pretty the same, but anyway, what do you think about Helm? Could I use Helm to simplify replacing secrets inside the Kubernetes email file? Or maybe you know best practice how to keep secrets in Kubernetes more secure and
Good question. Yeah, in our build, we went really old school, and we just used sed to replace those secrets into our Kubernetes YAML file. Now, we definitely didn't want to commit the secrets into place in our YAML file, because that would put secrets into our source code repository. We definitely don't want the secrets committed to source control. So I'm glad that we separated them out. Helm is a great project for being able to template and scaffold Kubernetes YAML files or any type of YAML file. And so we could separate this Kubernetes file into 3 files in our template, one for our deployment, one for our service, one for our ingress. We could have those replacement expressions as Helm replacement expressions instead of just a sed thing. And that would add a little bit more structure to our Kubernetes YAML file. In this case, we only had 3 pieces, so going old school worked out pretty well. But if we ended up with other things, a persistent volume claim, config maps or secrets, then flipping over to Helm might be a little bit more elegant way to be able to get some additional capabilities from YAML. We didn't have the complexity to justify it in this case, but if you have a more complex Kubernetes experience, then Helm could be a really elegant way for containing that Kubernetes YAML sprawl. Great question.
Yep. Some compliment from audience. You're a rock star. And next question is great presentation. Short question is a configuration CI, which our kubeconfig file is the best way to set up the connection with cluster. What are the other ways?
Great question. As you ask what is the best way, I have to ask this question. What is the best coffee cup size? Is it tall? Is it wide? Is it just regular size? I had one person answer, well, it's the size of the boss's coffee cup. And I would say the similar thing here. What's the best way? There are lots of different ways, and each one has their pros and cons, but I don't think there is a best way. There are some best practices, like don't commit the secrets, but I love this question of what are the other ways to authenticate to our Kubernetes cluster? Now, in this case, we use the kube config, and so I'm actually authenticating as me from the build into the cluster. And that's a little bit fragile because if ever I left the company, then the build would fail. That's not a solution that we want. So probably we want to make a build-specific user and use the kube config from that user. In this task, we could specify other scenarios like passing in a username and authentication details. And so those are the parts that we deleted once we added this task into our GitHub Actions build. But even better, it would be great to be able to authenticate from GitHub Actions to our Kubernetes cluster using role-based access control. And role-based access control, or RBAC, is brand new in GitHub Actions. So you can create a GitHub Actions RBAC authenticator and then authenticate your cluster into that. And once you have that connection, then there are no secrets connecting GitHub and your cluster. And at that point, yeah, there's no secrets to lose. We're authenticating based on the presence, based on the characteristics of the cluster and the characteristics of GitHub. All else being equal, RBAC is the best, but RBAC may be a little bit more complicated than what you needed. And so I went old school here and just copied my kube config into place. What's the best option? Well, it's the one that gets the build done for you, the one that gets the build automated. And in this case, that might have been the best option. Or if you had a little bit more time, a little bit more elbow grease, then maybe getting RBAC connected would be even better. Great question. Thanks for that.
Right, so it's last question for today, looks like. Anyway, I want to say thank you very much, Rob, for that you found time to join us. You have a great presentation. Of course, if audience have additional questions, feel free to find a website from Rob. I know that you have lots of interesting information on your website, and someone can ask you a question via Twitter or email. So feel free to ask Rob about different cases. It looks like he has lots of experience on Kubernetes. So it's awesome. Anyway, thank you very much, Rob.
Hit me up on Twitter. Here's my Twitter right here, Rob_Rich.
Yeah.
And grab the code, link to it from robrich.org, and you can get straight to the GitHub repository for this talk and fork or download the code and start building your DevOps pipelines in GitHub Actions as well.
Yeah, let's start to optimize all that we can optimize in our world. Okay,
Yes.
Thank you very much. Bye, Rob. Have a nice day, or what you have, evening, or maybe morning. Who knows where we are? Okay, bye.
Yep. Thank you. This was so much fun. Thanks for including me in the group.
Bye. And in the end, I want to ask our audience to leave a feedback. Please, want to improve our experience, and we want to know what you wish to knew for further meetups. Feel free to share your feedback after via this link. And I want to say thank you very much, all audience that watching right now us. And anyway, bye. See you for further meetups. Bye.